Jupiter, the first of the gas giants. Jupiter, the fifth planet from the Sun, and the largest of our solar system, sits just beyond the asteroid belt. Jupiter is made up predominantly of hydrogen. This basic gas accounts for 90% of its atmosphere. Nearly 10% is composed of helium. A very small fraction of the atmosphere is made up of compounds such as ammonia, sulfur, methane, and water vapor. The atmosphere of Jupiter lacks a clear lower boundary and gradually transitions into the liquid interior of the planet. From the lowest to highest, the atmospheric layers are the troposphere, stratosphere, thermosphere, and exosphere. Each layer has characteristic temperature gradients. The lowest layer, the troposphere, has a complicated system of clouds and hazes, comprising layers of ammonia, ammonium hydrosulfite, and water.
The surface of the planet, or the bottom of the atmosphere, is the point where scientists have calculated that the atmospheric pressure is equal to 1 bar, the same amount found at the surface of the Earth. The upper ammonia clouds visible at Jupiter's surface are categorized into a dozen zonal bands parallel to the equator and are bounded by powerful zonia atmospheric flows known as jets. The bands alternate in color. The dark bands are called belts, where the white light ones are called zones.
Like many of the planets in our solar system, Jupiter has moons. Yes, moons. There are 79 known moons of Jupiter. This gives Jupiter the largest number of known moons with reasonably stable orbits of any planet in the solar system. The most massive of the moons are the 4 Galilean moons, which were independently discovered in 1610 by Galileo. Io appears yellowish and distinctive, but yet it is very small, especially compared to the other moons. Io is the most volcanically active world in the solar system, with hundreds of volcanoes, some erupting lava fountains, dozens of miles high. Io is caught in a tug-of-war between Jupiter's massive gravity and the smaller but precisely timed pulls from 2 neighboring moons that orbit farther from Jupiter, Europa and Ganymede. Europa's surface is mostly water ice, and scientists have found strong evidence that beneath the ice crusts is an ocean of liquid water or slushy ice.
Jupiter has 52 moons. 8 are regular satellites with prograde and nearly circular orbits that are not greatly inclined with respect to Jupiter's equatorial plane. The Galilean satellites are nearly spherical in shape due to their planetary mass and would at least be considered dwarf planets had they a direct orbit around the Sun. The other 4 regular satellites are much smaller and closer to Jupiter. These serve as sources of dust that make up Jupiter's rings. The remainder of Jupiter's moons are irregular satellites with prograde and retrograde orbits that are much farther from Jupiter and have higher inclinations. 27 of Jupiter's irregular satellites have not officially been named.
Perhaps Jupiter is most recognizable by its most famous feature, a giant Great Big Red Spot, which is called Jupiter's Great Big Red Spot.
Are we being too literal?
First identified, the spot is actually a violent storm located just south of the planet's equator. Recent studies have indicated that the gigantic storm may be shrinking, as you can see in the photos taken over the span of a decade. Colder than the bands around it, the Great Big Red Spot must lie higher in the atmosphere. The source of its reddish color has not yet been established, but it varies throughout the region. We owe a lot of our knowledge to one major spacecraft, Juno. The Juno spacecraft was built by Lockheed Martin and is operated by NASA's Jet Propulsion Laboratory. The spacecraft was launched from Cape Canaveral Air Force Station on August 5, 2011, as part of the New Frontiers program, and entered a polar orbit of Jupiter on July 5, 2016. Juno so far has discovered that Jupiter's atmospheric winds of the gas giant planet run deep into its atmosphere and last longer than similar atmospheric processes found here on Earth. The findings will improve understanding of Jupiter's interior structure, core mass, and eventually its origin. The swirling massive storms raging across Jupiter's north and south poles are unique. Jupiter's north pole features one cyclone surrounded by 8 similar-sized cyclones, with diameters from all averaging between 2,500 to 2,900 miles. A third of the way into the planet, the hydrogen in the atmosphere becomes metallic, allowing it to conduct electricity. This helps to drive Jupiter's powerful magnetic field. The planet rotates rapidly, and the rapid spinning causes electrical currents in the metallic hydrogen to generate electricity that powers the planet's magnetic field. Extending up to 7 million kilometers in the Sun's direction and almost into the orbit of Saturn in the opposite direction, Jupiter's magnetosphere is the largest and most powerful of any planet magnetosphere in the entire solar system. Jupiter's magnetic field is almost 20,000 times as powerful as Earth. The electromagnetic storms they generate can be heard by amateur radio operators right here on Earth, beamed toward us by the plasmas and magnetic field lines. At times, Jupiter can produce more powerful radio signals than the Sun. An exciting planet that Jupiter is, its rotation is quite fast. A day on Jupiter lasts 9 hours and 56 minutes, which is known as a Jovian day. This means by 10 a.m. on a Monday morning, Jupiter has already gone into Tuesday. And yes, you're stuck living out the rest of your Monday here on Earth. All kidding aside, Jupiter's year, however, lasts 12 Earth years, which is known as a Jovian year. Easy to spot in the night sky, and even easier to view through any telescope, Jupiter continues to wow us from so far away. And as we continue to learn from Jupiter and its moons, we can still enjoy the beauty it displays here in our solar system. Until next time, be curious, be creative, and always